Okay, Assalamualaikum and hi. Today we will start vectors chapter. So you will study about vector and scalar quantity. What's the example of vector and scalar quantity? What's the difference? And next you will learn about identifying direction, north, south, east, west. You should know all the direction. What is unit vectors? How to draw? Of course, you have to know how to draw. Okay. And how to determine which one is component x and y, how to find x and y, how to find magnitude and direction. Okay, for at the first place, I will explain about vector and scalar quantity. So what is scalar quantity? What is vector quantity? Scalar. What is scalar quantity? Scalar quantity is the quantity that have magnitude. But vector quantity is the quantity that have magnitude and direction. What is magnitude means? Magnitude means value. Okay, values, numbers. Okay, that's magnitude. So for scalar quantity is the quantity that have magnitude only. For vector quantity is the quantity that have magnitude and direction. Okay, give me the example of scalar quantities. Very good. Scalar quantity, for example, mass 48 kilogram. Only value, right? Which is scalar quantity. What else? Time 5 seconds. So 5 seconds is the scalar quantity. There's no direction. Distance 18 kilometer. So 18 kilometer is the scalar quantity, or the distance is a scalar quantity. What is about vector quantity? Vector quantity, the quantity that have magnitude and direction. For example, displacement. Displacement actually same with distance. The definition also distance, the length of something from point A to point B, but displacement is, for example, 18 kilometer to the east. It means to the east is the direction, or 20 kilometer to the right. So 20 kilometer is the magnitude. Right is the direction. That's why they call displacement. That's the difference between distance and displacement. But the unit both are same, which is meter. Another example for vector quantity is the velocity. Scalar quantity is the speed. Speed, for example, you drive a car with 20 kilometer per hour. Oh, it's too slow. 20 kilometer per hour. Okay, so this one is a speed. Okay, velocity means 20 kilometer per hour to the north, or 120 kilometer per hour to Unit 10. Means from your home to Unit 10 is the direction. 120 kilometer per hour is the magnitude. For this case, 20 kilometer per hour is the magnitude. To the north is the direction. Okay, that's the difference between scalar and vector quantity. Okay, now we move to distance and displacement. I will explain more about distance and displacement. So, distance, the symbol is D, distance. Displacement is delta x. Okay, what is distance? Distance is a scalar quantity. Displacement is a vector quantity that have magnitude and direction. For distance, only have magnitude only. The unit both are same, which is meter. The unit meter. But what's the difference between distance and displacement? Okay, distance, for example, from point A to point B. So 4 kilometer, 2 kilometer, 5 kilometer, 7 kilometer. So what's the distance? Distance is equal to 4 plus 2 plus 5 plus 7. So how much? 18 kilometers. So here is the distance, only magnitude, which is scalar quantity. Displacement means from A to B. Displacement means the shortest way from here. So the shortest way from point A to point B is the straight line. For example, if you want to go from CES building to for example, from library to admin building in Unit 10. So you have to go by bridge. It is the shortest way, right? So that one is the displacement. If the longer way, you have to walk to ITMS in front of the admin building. That one is distance. So the shortest way, here will be your x initial, here will be x final. So for example, delta x is equal to 5 kilometer. So your displacement should be 5 kilometer from A to B, for example, or 5 kilometer to the right. So 5 kilometer is the magnitude, from A to B is the direction. Okay, 5 kilometer is the magnitude, to the right is the direction. I explain details about this in motion in one dimension. Okay, so both of these are same, but displacement have direction, distance don't have direction. Distance is the longer way. Displacement is the shortest way. That's the bird chirping sound. Okay, that's for distance and displacement. Clear? Very good. Okay, now we move to identifying direction. How to identify direction? First of all, we have to draw axis. You should know where is north. Where is north? Upward, very good. South, downward. East, west, east. Right or left? East should be right, west should be left. Okay, here is the axis. Now we in this chapter we learn about vector, right? So vector, of course, you have magnitude and direction. First, this is the axis. Now we want to identifying direction. Identify direction. Okay, for example, I give you one vector. For example, vector A. Vector A with the magnitude, we call this one as magnitude, with the magnitude of 10 kilometer with an angle of 30 degree. How to pronounce this direction? Oh, very good. Some of you know about this. So how you pronounce vector, you should have magnitude and direction. R is the magnitude, theta is the direction. So how you determine this vector A? Vector A with an arrow because it's a vector quantity. 10 kilometer, comma, 30 degree north of east or east of north. Very good. North of east. Please remember 30 degree lies on east, right? So east should be at the second direction. So how you pronounce 30 degree? 30 degree north of east. North of east. Understand? Means 30 degree at east. 30 degree at east. I give you another example. For example, vector B with the length of 5 kilometer with an angle of 50 degree, for example. How to pronounce vector B? So vector B is equal 5 kilometer, comma, 50 degree north of west or west of north. Very good. You're fast, very fast learner. So 50 degree west of north, because 50 degree at north, so you should pronounce at the second place. Okay, west of north. I give you another example. Vector C is equal to 53 meter with the angle of 20 degree. How to identifying this direction? C is equal to the magnitude 53 kilometer, comma 20 degree west of south or south of west. 20 degree lies on south, so south should be at the second place, so you should pronounce west first of south. So 20 degree at south. Okay, the last example is quite special. Vector D. Vector D with the length of 10 meter, for example, with an angle of 45 degree. So how to pronounce this one? Vector D is equal to 10 meter, comma 45 degree south of east. Okay, very good, because 45 at east, right? But as you know, this angle is 90 degree. 45 is half of 90 degree. So you can even identify 10 meter, 45 degree east of south, because this one also 45 degree. Clear? Because total of this angle is 90 degrees. So whether it's here or here is still same 45 degree, 45 degree. So both of these are acceptable. Or sometimes in the question they will state that D is equal to 10 meter southeast. They didn't state the angle, it means 45 degree. Or vector D is equal to 10 meter east south. So east south, southeast, no angle means 45 degree. So these four directions are acceptable. If you see this kind of direction, or if you want to explain this direction, these four direction should be acceptable. Okay, only valid for 45 degree. Okay, clear, very good. Now we move to unit vector. What is unit vector means? Okay, every quantity that have unit, same with the vector. Okay, vector also have unit, which is I and J. Sometimes you write I with a cap, J with a cap, or sometimes in your school you will state I with the wave. You learn in additional mathematics, which is also acceptable. If you want to use cap or wave, is still correct. Okay, what does it mean by I and J? I and J, I to show X exists, J to show Y exists. Very good. Okay, I give you one example. For example, vector A is equal to 2I plus 3J. For example, vector B is equal to 3I minus 8J. Okay, this is the vector given by the questions. So first, maybe they will ask you, draw the vector. Please draw C is equal to A plus B. So first of all, you have to draw the original diagram first. So here is x-axis, here is y-axis. So 2I plus 3j. So vector A position is at 2I, means 2 at x, 3j, so 3 at y. So here will be your vector A, the original vector, okay, vector A. Vector B should be 3i minus 8j, so 3 at x because positive, so at right, first quadrant, minus 8j, so negative 8y is here, so here will be your vector B. Please put the arrow like this and put the arrow like this, means to show the direction of the vectors, okay? This is the original vectors. So how you draw A plus B is equal to C. So A is like this, so you draw A, same with that, plus B. So B is downward, right? So from first vector, continue with the second vector. First vector, continue with the second vector. If you're from your house to your school, to your university, so house, go to the mark and go to the university. Okay, so please start from the starting point, first vector, and move to the second vector. So where's the C? C means the displacement. A plus B means the distance. So where's the shortest way? Very good. Please start from the starting point to end point. So arrow like this. If you put opposite arrow, if you draw opposite arrow, will be wrong. So here will be C. Clear? Very good. That's how you draw A plus B is equal to C. How about if I ask you D is equal to A minus B? Please draw A minus B. So I draw it here, okay? So A is positive, right? So positive, same direction. So same direction of A. But this one, just now is positive B, now negative B. Positive B in this way, so negative B should be, very good, opposite way. So opposite way, negative B. So here will be A plus negative B, you will get A minus B. So where's the D? D should be from starting point to end point. So here will be D. That's how you draw vectors. Okay, now what if the next question they ask you about